Hello everybody, this is Thurtner here with another ASMR video. This is indeed one of my highest activities I think I've had in a very, very long time. This may amuse some of you people, or it may not. Today I will be doing chemistry homework. Specifically, if you're curious on what's on it, is acid base. And it has to do a lot with equilibrium. Now, you will obviously hear returning to pages, writing, and I will even speak as I am doing the problems on my mindset through them, how I'm doing them and everything. Obviously, I'm not showing the problems as I believe heavily in a dark background, and it makes editing significantly easier because you essentially just watch through the video. As long as the sound's even remotely alright, you've got a good video right there. So let's begin. Right now, I only got this idea halfway through a problem. I am currently calculating the pH of each of the following set of solutions. The first one is 0.1 molar. Molar is moles over liters. And this is of CH3 NH3 Cl. So, first for this equation, you write a balanced formula, and you can just cross out the Cl. It's just going to be, I'm blanking on the word right now, but it's not going to affect any of the outcomes as it, it's going to be a spectator ion, that's what I meant. So, CH3 NH3 plus H2O, you add water because it states in the question reacts with water, and you do need to have that to really measure the pH. And then that's going to produce CH3NH2. The original CH3NH3 gives one hydrogen ion to water to make it hydronium. And luckily, I do have, not textbook, but I have looked at the values online, and the KB for this particular one is 4.4 times 10 to the negative 4. Now, one little trick is that KB times KA equals KW. KW is 1 times 10 to the negative 14. So 1 times 10 to the negative 14 divided by 4.4 times 10 to the negative 4 equals Ka, which is 2.27 times 10 to the negative 11. And we need Ka because this is producing hydronium, which means that it's giving another hydrogen to water. And whenever it is doing that, we are measuring that extra hydrogen concentration in order to find pH. Now, to some of you people who have not taken chemistry that is advanced, you probably understand the basic idea of pH. 7, below 7 is acidic, above 7 is basic, 7 is neutral. That is a very simple concept. And yes, it is true. No one's been lying to you, I swear. But you never really talk about how P means negative log of something. And that's what gets you that number. So in reality, H for something that has pH of 14 is 1 times 10 to the negative 14. That's what H is, and by H I mean the concentration, which is also measured in molarity. Now for this particular problem, at Ka that I talked about earlier, 2.27 times 10 to the negative 11, we are going to set that equal to x squared over 0.1 minus x. This is the same for every single basic chemistry problem. Essentially, you take into account how much the various concentrations change. And CH free and H free starts out at 0.1. So 0.1 is going to change by some unknown variable. It is going to subtract that variable as it is a reactant. And in the two products, H3O plus and CHNH2, or CH free NH2, that's what I meant, is also going to add by the exact same amount as they both have the same coefficient of 1. This is not exactly equilibrium that we are talking about. The coefficients does not also result in squaring or whatever. It would not matter for this one because none of them have a coefficient of 2 or 3 or any of that. But for those, you also raise the power. But anyway, 2.27 times 10 to the negative 11, it was x squared over 0.1 minus x. In my calculator, which is a TI-89, I have a particular it's basically just called solve. It solves very basic algebra problems and even some of the harder ones as well. So x equals 1.51 times 10 to the negative 6. And x is going to be the concentration of H free plus. So negative log of 1.51 times 10 to the negative 6 is going to be the pH. This should roughly be around, I don't know, 6 or so, maybe 5. I'm not quite that good of guessing those quite yet. At 5.82 is the pH, and I do have sorry, that was a text message that I was getting back to, but now I will check the answer, and I do see that the answer is 5.82 for the pH. time to go to the next problem. Now, this is sodium cyanide, or NaCN, 0.05 molars of it specifically. Now, as I said before with the last one where we've completely and utterly ignored chloride, we are going to completely and utterly ignore sodium. So we're going to write Cn to the negative, because it's going to be negative, plus H2O. There's an arrow sign in chemistry for balanced equations. This has a double arrow as it is an equilibrium equation. You can also write in the states of matter. You should definitely do it for tests. Personally, for just notes and stuff like that, unless I'm learning something new, I don't do states of matter. Because unless stated otherwise, H2O is almost always a liquid. It's almost always in liquid form for any chemistry. Alright, so Cn minus, so this should be HCN. It'll be a neutral charge because hydrogen is positive, although it can be negative if it is bonded with other non-metals. But that plus OH minus, and OH minus is just hydroxide for anyone who's not a big chemistry person. Now, Cn minus has an initial concentration of 0.05 molar. H2O is completely and utterly not considered as it is water. Water is a liquid, and we do not consider liquids nor solids for this. Now, hydrogen cyanide does not have an initial concentration that we know of. So its initial concentration is 0. Hydroxide's initial concentration is also 0. But we do know that both of these are going to change by a certain value. And it's going to be the same value for both of them. And the cyanide is going to lose by the same value, as they all have the exact same coefficient of 1. So HCN is going to be X. Hydroxide is going to be X. Cyanide is going to subtract X from 0.05. Now, we happen to have Ka for this problem. Ka equals 4.9 times 10 to the negative 10. Now, Ka does nothing for us here because this is not producing hydronium, or if you shorthand it and don't add in the water, you could also just see it as a hydrogen ion. It is only